All right, welcome everyone to the Friday Tech Talk. And today's talk, we have Ian McAllister. He is a very recent Tech Academy graduate from our Artificial Intelligence Bootcamp. He did very well with the program, and he's really enthusiastic and really enjoys data science and artificial intelligence. His passion should come through in the talk. And today, Ian will cover the critical role unstructured data plays in AI and data science. He will give insights into techniques and tools for analyzing these complex data sets. And he will also show how to use real-world applications and strategies that can help you leverage unstructured data effectively. With that, without further ado, Ian, take it away.
Awesome. Thank you so much, Rick. So hello, everyone, and thank you for joining me today for this talk, Developing with Unstructured Data, Unlocking New Possibilities in AI and Data Science. As Rick said, my name is Ian McAllister. I'm a Tech Academy graduate from the AI Developer Bootcamp and a technical product manager with a strong focus on AI, data science, and product development. So throughout my career, I've been deeply engaged in the world of innovation and process optimization, working on solutions that bridge the gap between cutting-edge technology and real-world applications. Beyond my day-to-day work, I host the Unstructure My Product podcast, where we explore trends and challenges in AI and product management. I also lead the Product Lunch PDX Meetup, which brings together professionals and enthusiasts to share ideas and advance the field. So today we're going to be diving into a fascinating and increasingly important topic, unstructured data. We'll explore why unstructured data matters, how vector embeddings work as a transformative tool, and what this means for databases and document storage. So let's kick things off. In the early days of computing, data was entirely structured. We worked with tables, rows, columns, key value pairs. This made it easy for computers to understand, but limited how well we could capture the complexity of the real world. But with the rise of machine learning, we've unlocked the ability to process and derive insights from unstructured data, things like text, images, and audio. This has been a game changer. Machine learning doesn't just help us automate tasks like generating recommendations or personalizing experiences. It enables us to uncover patterns in data that were once too complex for traditional methods. So these advancements are transforming fields like search, personalization, and automation. And they're driving forward applications in natural language processing and image recognition, enabling everything from real-time translations to medical diagnostics. So let's take a step into this and see what it means. So unstructured data is all around us. Examples include text, images, audio, and video. Unlike structured data, which fits neatly into rows and columns, unstructured data doesn't follow a predefined schema. It's messy, inconsistent, and comes in a wide variety of formats. This diversity is what makes unstructured data so powerful, but also incredibly challenging to work with. To make sense of it, we need tools that can interpret the data and understand its context. For instance, reading text requires understanding language and meaning, while analyzing images requires recognizing patterns like shapes and colors. This is exactly where machine learning shines, by using algorithms to find patterns, extract features, and even understand the meaning embedded in unstructured data. We're able to unlock its value. As we progress, we'll see how this capability lays the foundation for innovations like vector embedding, which enables systems to transform unstructured data into something that can be indexed, searched, and analyzed efficiently. So to truly understand how machines handle unstructured data, let's compare the traditional approach to the machine learning approach. On one side, we have the traditional method, where humans predefined a structure for data. Think of creating categories, schemas, or models to fit information into. While this works well for structured data, it's not practical or even possible for unstructured data because of its sheer complexity and variability. On the other side, we have the machine learning approach. Here, instead of humans imposing a structure, algorithms are trained to derive structure automatically. Machine learning enables systems to analyze and identify patterns in text, images, audio, or video, effectively creating order out of chaos. So this is a fundamental shift in how we interact with data. By allowing machines to extract meaning and structure on their own, we eliminate the bottleneck of manual intervention and open the door to processing far more complex data sets. So here we can see a simplified view of a convolutional neural network, or CNN. This is a type of neural network commonly used for image recognition tasks. The process begins with an input layer, in this case, an image of a dog. From there, the model applies a series of convolutional layers. These layers detect patterns like edges, textures, or shapes, and pass that information forward. After each convolutional step, a pooling layer simplifies the data by reducing its size, focusing on the most critical features. Once the network has extracted higher level patterns like ears, a nose, or fur, it connects these features through fully connected layers, ultimately arriving at predictions like dog, cat, or other categories. This layered approach enables machines to learn complex patterns automatically, making it possible to analyze and understand unstructured data like images. It's the same concept applied to text and audio, but with different techniques and tailored for each different data type. So now that we understand how neural networks process data, let's talk a little bit about the key steps in getting the most out of machine learning and finding the right model. So in this slide, we can see on the right, the model is it's a balancing act. On the left, we see an underfitted model. This model is too simple. It fails to capture the underlying patterns in the data. It's like trying to fit a straight line to a set of data points that are clearly more complex. The result, the model misses the important nuances, leading to inaccurate predictions. In the middle, we have the ideal model. This model strikes the right balance. It's just complex enough to capture the meaningful pattern in the data without overcomplicating things. It's accurate on both the training data and new unseen data, and this is what we're aiming for. Then finally, we have an overfitted model. Here, the model is too complex. It's memorized every detail of the training data, including noise and anomalies. While it might perform very well on the training set, it struggles with presenting the new data because it can't generalize. The key takeaway here is that the most effective model lies somewhere in the middle, where it can recognize the real pattern in the data without overanalyzing or missing the bigger picture. So let's take a closer look at the process of model fitting in a neural network. At its core, the goal of model fitting is to optimize the weights and biases within the network. These are the parameters that the model adjusts during training in order to learn properties in the data. By minimizing error, often through a process called gradient descent, the model becomes better at mapping inputs to outputs, whether it's making a prediction or performing categorizations. So what makes this process exciting is its predictive nature. Once the model is trained, it can take a new input, something it's never seen before, and produce the most statistically relevant output based on the patterns. It's learned during this training. For example, if you feed an image of a dog into an image recognition model, it predicts dog because that's what the data suggests is most likely. This ability to generalize is what makes neural networks so powerful and why I'm so excited about them. Whether it's identifying objects in images, recognizing speech, or predicting future trends based on past data, the trained model serves as a dynamic predictive tool. So here we're looking at the gradient descent model. To understand how neural networks optimize their performance during training, we need to explore gradient descent, a key algorithm that minimizes the model's loss or error. Imagine this graph represents the loss function, with the vertical axis showing error and the horizontal axis representing the model's parameters like weights and biases. The goal of gradient descent is to adjust those parameters in such a way that the model moves downhill step by step toward the lowest possible error. The process happens in several steps. First, we have initialization, where the model's weights and biases are set to a starting value. Then comes forward propagation, where the model makes predictions based on the current parameters and calculates the loss. Next, in backward propagation, where the algorithm computes gradients, essentially the slope of the loss function, to determine how the parameters need to change. During the gradient update step, the model adjusts its parameters slightly, moving closer to the optimal point. Finally, this process repeats or iterates multiple times, steadily improving the model's accuracy. What's remarkable is how efficiently gradient descent works. Even with massive data sets and complex neural networks, it's the backbone of modern machine learning, enabling systems to learn and improve by minimizing errors step by step. Here we see three types of data being fed into an embedding model: images, documents, and audio. These are classic examples of unstructured data, rich in content, but messy in format. The role of the embedding model is to transform these diverse inputs into a unified representation, vectors. A vector is essentially a series of numbers that encode the key features of the input. For example, the vector for an image might capture characteristics like shapes or textures, while the vector for a document encodes relationships between words and concepts. The beauty of this approach is that the vectors exist in a mathematical space, where relationships between data points become meaningful. Similar items like documents with related topics or images with similar content end up close to each other in the space. This makes possible the performance of similarity searches, clustering, and classification, even across different data types. So by converting unstructured data into vectors, we unlock entirely new possibilities for search, personalization, and automation. So now that we've introduced the idea of vector embeddings, let's dive deeper into what they are and why they're so powerful. At their core, vector embeddings are encoded numerical representations of data. They take something unstructured, like an image or a piece of text or even audio, and represent it as a vector or a list of numbers. So here's an example. On the top, we have an image of a bird sitting on a branch. And on the bottom, we see the text, a bird on a branch. Although these inputs are in completely different formats, an embedding model can process both the generated vectors that represent their meanings. What's remarkable is that these vectors capture similarity and context. The embedding model recognizes that the image and the text are describing the same concept, so their corresponding vectors end up close to each other in the mathematical space. This ability to encode meaning, similarity, and context is why vector embeddings are such a powerful tool. They allow us to compare and connect data across different modalities, like finding text that describes an image or clustering similar audio files. So based on their underlying representation. With this foundational understanding, now let's explore how embeddings enable practical applications in AI and data science. Unstructured data in databases. Traditional databases, like relational databases, are designed for structured data. They rely on rigid schemas, predefined structures for how data should be stored and queried. This is perfect for structured data like numbers and dates, but it's not flexible enough to handle the messiness of unstructured data like text, images, or audio. To accommodate unstructured data, we need new paradigms. This is where technologies like NoSQL and document stores come in. These systems are designed to be more flexible, allowing data to be stored without rigid schema. They handle the complexity and variability of unstructured data, making it easier to store and retrieve it. Some popular examples of flexible databases include MongoDB, Elasticsearch, Firestore. These databases support unstructured data by allowing more dynamic storage structures, making them perfect for modern applications like search engines, recommendation systems, and AI-driven products. Now let's compare two common types of databases, row-based SQL and document-based NoSQL, and see how each handles data differently. On the left, we have row-based databases like traditional SQL systems. These are designed around a fixed, structured format. Each row in a table has a predefined set of columns, making them excellent for transactions where consistency and structure are key. Think of applications like banking systems or inventory management, where you need strict data integrity and predictable formats. On the right, we have document-based databases, which are part of the NoSQL format family. These systems are much more dynamic. They store data in a flexible format, often using JSON-like documents that can include complex, unstructured data like text, images, and even embedded arrays. This flexibility allows them to handle rich, unstructured content, making them ideal for applications that deal with large amounts of unstructured data, such as content management systems or modern AI-driven platforms. In the overlap, you see how these two types of databases can complement each other. For example, an application may use a row-based system for financial transactions while relying on a document-based system for handling unstructured data like user profiles, content, or logs. Let's begin with BigQuery, a powerful data warehouse for structured data. Here we can see how BigQuery organizes data in tables, which is typical of traditional SQL databases. Each table has predefined columns and rows, ensuring that the data is consistent and well-structured. This makes it ideal for large-scale data analysis and querying. In BigQuery, you might store sales data, user activity, or transactional records, all of which require structured schemas for efficient querying and analysis. BigQuery is a perfect choice when your data is highly structured and you need to perform fast, complex analytics across large data sets. Now let's shift gears to Firebase, which is a NoSQL database that I enjoy using that stores data in a more dynamic document-based format. In this screenshot, you can see that Firebase stores data as documents within collections rather than rows in tables. Each document can have varying fields and structures, making it more flexible. You can store anything from user profiles to real-time chat messages. The different fields in each document, this makes Firebase perfect for applications that require flexibility like mobile apps or content-driven platforms. Unlike BigQuery, Firebase doesn't require a rigid schema, allowing you to store and scale unstructured data as needed. So to recap, BigQuery excels at handling structured data with a clear tabular format, while Firebase is designed for more dynamic document-based storage. These two systems highlight the difference between relational databases and NoSQL document stores, and demonstrate how we can approach unstructured data in different ways depending on the application's needs. By understanding these different storage paradigms, we can choose the right database to support any AI-driven application. So now that we have a little bit of an understanding of how unstructured data is stored and represented, let's take a look at some of the tools we can use to work with it. For data processing, we have powerful libraries like Pandas and NumPy. These tools are essential for handling, cleaning, and manipulating large data sets. While Pandas is perfect for working with structured data and tables, NumPy provides efficient numerical operations, especially when dealing with unstructured data like images or audio. When it comes to machine learning, TensorFlow and PyTorch are the go-to libraries for building and training models on unstructured data. Both frameworks support deep learning techniques, which are crucial for tasks like image recognition, natural language processing, and speech-to-text. TensorFlow is known for its scalability, while PyTorch is praised for its flexibility and ease of use. For storing and retrieving unstructured data, tools like MongoDB, Firestore, Elasticsearch are widely used. The NoSQL databases are designed to store dynamic document-based data that doesn't fit neatly into rows and columns, making them ideal for unstructured content like user data, logs, or search indexes. Finally, for visualizing unstructured data, Plotly and Seaborn are excellent libraries. These tools allow you to create interactive and static visualizations, helping you understand complex patterns in your data and communicate insights effectively. Whether you're visualizing the output or the machine learning model to summarize the data sets, these libraries help you bring your data to life. So while unstructured data offers exciting possibilities, there are several challenges that come up with it. First, we have the computational cost. Unstructured data by its nature is much larger and more complex than structured data. It requires more storage and more processing power to handle. For instance, storing and analyzing millions of images or processing long audio files can be resource intensive, especially when dealing with large-scale databases. This means we need to invest in more powerful infrastructure to optimize our workflows for efficiency. Next, there's the complexity of working with unstructured data. Unlike structured data, where patterns are more easily identified, unstructured data requires sophisticated algorithms to process and analyze. Machine learning models, particularly deep learning, are needed to extract meaningful insights from images, text, or audio. These algorithms are more complex, they require more data, and take longer to train than those for unstructured data. Finally, we have the challenges of interpretability. When working with unstructured data, it can be much harder to validate the insights we generate. For structured data, we can easily trace how a particular output or insight was derived. But with unstructured data, like when using deep learning models or images or text, the black box nature of these models makes it more difficult to explain how they arrived at their conclusions. This presents a challenge for trust and validation in industries where transparency is critical. Despite these challenges, the benefits of unstructured data, its richness and potential are undeniable. As technology and algorithms continue to advance, we'll be better equipped to tackle these hurdles. So as we look at the future, there are several exciting trends emerging in the world of unstructured data, especially in AI and data science. First, we're seeing the growth of multimodal AI. This refers to the ability of AI models to work with multiple types of data, like text, images, audio, and video simultaneously. By combining different modalities, we can create more sophisticated models that understand context in a more holistic way. For example, a multimodal AI system could process both image and its associated caption to generate better insights, making it more versatile in applications like content moderation, autonomous vehicles, and personalizing recommendations. Next, we're witnessing advances in embeddings. Over time, embeddings have evolved to become more contextual and domain-specific. Rather than relying on general purpose embeddings, we're moving towards models that can create embeddings tailored to specific industries or tasks, whether it's healthcare, finance, or customer service. These advanced embeddings allow for more accurate and meaningful representations of data, making it easier to extract valuable insights from unstructured content. So finally, generative AI is making a huge impact on data processing and analysis. Generative models like GPT and other deep learning architectures can not only analyze unstructured data, but also create new content from it. This could include generating text, creating synthetic data, or even generating new images or videos. In generative AI, As it continues to evolve, we will significantly enhance how we process and interact with unstructured data, enabling us to create more realistic simulations, enhance creativity, and automate complex tasks. These trends tend to highlight the incredible potential of AI and unstructured data to transform industries and redefine what's possible. It's an exciting time to be in this field. So as we wrap it up, let's revisit the key takeaways from today's talk. First, unstructured data is the future of AI-driven insights. While structured data has been the foundation of analytics for decades, unstructured data, like text, images, and audios, is rapidly becoming the most valuable resource in AI. Its richness holds untapped potential, enabling machines to understand and create in ways we haven't seen before. Next, vector embeddings are the key to unlocking this value. They allow us to transform unstructured data into a format that machines can process and understand, capturing meaning, context, and similarity. So whether it's natural language processing, image recognition, or search, embeddings bridge the gap between diverse data types, making them one of the most powerful tools in AI today. Finally, embracing new tools with paradigms is essential to building cutting-edge applications. The shift towards flexible databases, advanced machine learning frameworks, and powerful data processing tools gives us the capability to not only work with unstructured data, but to harness it to drive innovation. Whether you're building the next breakthrough in search technology or designing personalized recommendations, these new tools are key to unlocking the full potential of AI. By embracing unstructured data, vector embeddings, and the latest tools, we can shape the future of AI and data science. The possibilities are endless, and the journey is just beginning. So as we conclude, here are a few ways you can get started with unstructured data and continue your journey in AI. First, explore unstructured data in your projects. Whether you're working on a personal project or a professional one, there's no better time to incorporate unstructured data. Dive into different data types like text, image, or audio, and see how you can unlock new opportunities in your application. Next, I challenge you to build a personal project using embeddings, such as implementing semantic search. By experimenting with embeddings, you'll not only deepen your understanding of how it works, but you'll also get hands-on experience in one of the most exciting areas of AI. Finally, stay curious and keep learning about advancements in AI. The field is evolving rapidly, and there's always something new to discover. Keep exploring, stay updated with the latest research, and embrace the innovations that will drive the next wave of AI applications. Thank you all so much for your attention today. I hope this talk has sparked some ideas. I would love to connect with you all. Feel free to connect with me on LinkedIn. And without further ado, any questions from anyone that I can answer?
Yeah, we do have some questions, Ian.
Yeah.
So now the questions are in the chat, but I will ask them. I will ask them aloud for you.
I appreciate it.
So what we have. So Lauren asked, so Firebase is a file system storage, and I kind of answered the question. I said it's a NoSQL document-based storage system or unstructured data.
Yep.
And I think Lauren wants to know where the data is stored, and I assume it's like servers and maybe data centers, that kind of thing. But can you elaborate on that?
Yeah, definitely. So Firebase is cloud-based. It's a product that Google offers. They have a great program. They are trying to get new developers into it, so you can use it free until you get to some level of traffic. So I use it for every project that I do just because it's so versatile and so easy to access. Does that answer the question?
Yeah, no, it does answer it. And how much storage do they give you before you have to go to the page here?
It's less about storage. It's more about reads and writes. I want to say it's like 10,000 daily reads and writes before they start charging you.
Got it. All right. And yeah, Lauren, I hope that answers your question. Let's see.
Feel free to jump in if you want to ask anything else.
All right. So we've got a question from Even, and he asks, what would give me the strongest edge as a junior developer to be attractive as a new hire in AI?
Good question. And I think the hard piece is everybody's trying to figure it out right now. There's lots of talk, there's lots of excitement around it, but then there's also lots of what am I trying to say? internal products or internal solutions that people are building just by using ChatGPT to optimize their own processes. People are playing around with it, even though solutions aren't being rolled into businesses yet. So what should you focus on? I think the most important thing is what interests you. There's a lot of different sources you can read about what's happening in the space. I think just picking something as a developer, I think it has some context with the data that you have access to in your organization. If you have access to text, if you have access to audio and video, most people are going to have access to text before audio and video because we don't really have data pipelines set up for audio and video ingestion in most organizations. But if you can find ways to derive insights from customer comments or one big space is most organizations have lots of data that's stored in spreadsheets and emails that doesn't get disseminated through the organization. If you can figure out a way to wrangle some of that data for your organization, they will love you. There's a lot of people talking about this right now.
All right. No, that's great insights into AI, and I need to get into it more myself. I've kind of brushed on it, but I need to do a deep dive. It's amazing the presentation you just had, and just how much you've learned with getting into AI, and how much you've done as well. So you've got your own YouTube channel. You've created your own meetup. You've created your own meetup group. That's taking the bull by the horns. That's definitely taking the initiative. So that's awesome.
Thank you. It's fun.
So Petula has raised her hand, so I'm going to unmute her mic and I'll let her ask her question. Okay.
Yeah.
All right, Petula, you can ask your question.
Thank you. Can you hear me okay?
I can hear you.
Okay, I can't go on my camera, but that's okay. So my name is Petula Brown, and actually I work in healthcare IT specifically, and I've worked with EMRs for over 15 years.
Yeah.
And I was intrigued by this presentation because I'm not sure your industry experience, but mine being in healthcare, know that a lot of healthcare data is unstructured. And we're talking things like progress notes, images from radiology, pathology reports. So I think there's a lot there, but healthcare data is also very security sensitive. And I believe it's generally known that unstructured data is less secure, quote unquote, than structured data. So I don't know your professional or personal opinion on any of this, but I'm curious to see, to what extent you have a thought on this or can, direct to, others who might have a perspective.
Yeah, no, definitely. So I actually have lots of thoughts in this space. I've been educating myself on this Portland-based company called SkyPoint that I've been developing some friendships with right now. It is run by Tissin Matthews, who used to be the CTO of Cambria Health here in Portland, but now has been running SkyPoint for the last, I want to say it's 6 years. But their whole emphasis is on going into healthcare systems and pulling out the unstructured data and allowing companies to query their unstructured data. A lot of that process is building pipelines to bring the documents, most of them in PDF form, into their data lake, and then to extract the necessary information from these documents, move them into SQL, where they can be queried more easily. But they are definitely finding paths through all of the HIPAA requirements and ways to take a process that took way too long before, because part of the trouble in the healthcare space that you allude to is they have these legacy systems for reasons, and a lot of these legacy systems produce PDF documents and things like that, and they need to maintain those legacy systems. I know SaaS products have tried to come in and provide a solution for them, but in a lot of cases, these hospitals still have these legacy systems that produce all of this unstructured data. So I think SkyPoint is genius in that they figured out a way for the healthcare system to maintain its current systems and derive insights from this unstructured data. So I would encourage you to look more into what this company is doing here in Portland. I don't know if you're Portland based.
No, I'm not. I'm actually in Michigan. And we should connect offline because I think there's a lot of new technologies. And I think in healthcare, I focus specifically on using technology to improve health equity, right? So there's a whole lot that can be said about healthcare and AI and all of this. But I appreciate hearing about SkyPoint.
Yeah, I mean, please, let's connect. I would love to continue the conversation.
Okay.
Yeah, no, that's a great question, Petula. And yeah, it's It is obviously unstructured data in healthcare. That's a big industry that's going to use it. What other industries do you see making the most effective use of unstructured data?
Question to me. So I've also heard about in the insurance space. This is a space also that has lots of legacy systems that they can't move as quickly. There's this company Stretto that's trying to leverage processing unstructured data in order to find trends and insights, so that they can help their clients reduce risks, reduce insurance premiums, things like that.
All right, good stuff. And if anybody does have a question, you're welcome to leave it in the chat, or you can raise your hand like as Petula did. And so what do you foresee some of the ethical concerns or privacy issues when working with unstructured data?
Yeah, so I mean, the biggest thing is in most places, it's avoiding PII, personally identifiable information, how to keep that out of databases in case those are hacked, how can you encrypt the data at rest, how much information can you derive without pulling in that information. There are ways that people are, what am I trying to say, obfuscating. If you do have to collect PII, you can put the unstructured data in another place, so it's not as easy to match those up. These are different techniques I've heard about people using, but I would love to learn more about how people are navigating it.
And just off that, what practices what practices should be followed to ensure unstructured data is used properly?
Yeah. I mean, I think that while there is fear behind things getting out of hand or used improperly, and it goes into lots of spaces from model training that increases bias, things like that, I think that those are not fringe case scenarios, but there's so many applications for processing unstructured data that I feel like don't fall into spaces that could compromise integrity, business models. I had to navigate a situation with a company I worked at recently where we were talking about our first AI project, and the lawyers were putting up lots of red flags saying, we need to wait till some of these lawsuits go through to see what we're allowed to store. But we were able to paint the picture that I was working in a media company at that time, and all of the stuff that all the unstructured data that we were processing existed out in the public. Everybody could see it. There was nothing proprietary about it. Us deriving insights from it is nothing our competitors could steal. So I think that there is a lot of space, even though there are these fringe risk scenarios.
All right. Yeah, the ethics, just data in general, and data science and unstructured data, just the ethics with artificial intelligence also. Mm-hmm. It's going to be interesting to see where it goes over the next, few years.
Yeah.
Looks like Petula has another question for you, so I will unmute her microphone. And Petula, go ahead.
No, I didn't have a question. I actually had an answer to that question.
Oh,
because, okay. This is Ian, your show, but I'd be interested in your thoughts because I actually presented at a symposium at University of Michigan where I'm on the faculty, focused on electronic health and AI, and the whole point of basically a design processes and audit processes, so that at the design stage, you ask some sort of forthright questions in the development process. And then when you get to the end, before you roll it out as part of the QA process, there's different types of audits that you can do to address these things. And I've got a whole poster that explains all this from the presentation I did earlier this year. So I just want to throw that out there. And, I linked in with you, via LinkedIn if you're interested in that.
So cool. Yeah, I'd love to dig deeper.
Yeah, thanks, Petula. That's awesome. And we'll have to, we should do a show with you. Let's see, it looks like Even has another question. So he asked, what legitimate certifications are available for AI online today?
What legitimate certifications? Well, obviously the Tech Academy has a certification that you can go through, and that's where you should look first. I know that Amazon is offering their own, Google is offering their own, and it's just going to be a balance between price point. I want to say some of these are like $200. You spend 3 weeks, something like that, which is the best to get. I think it depends a little bit on the target that you're going into. Are you in the Google ecosystem? Are you in the AWS ecosystem? Are you in the Azure ecosystem? We'll probably speak to what is the best certification to get.
So, and with a 3-week certification, what would your prior prerequisites need to be?
Most of these ones that I have looked into are just tend to be familiarity with data processing and programming in general. They weren't terribly high bars. I think it's a space that there's lots of excitement around. Machine learning has been around for 15, 20 years. It's just now hitting an inflection point. So I do strongly believe that you can quickly upscale in this space and become competitive in this space.
Yeah, would you say that would require like some fundamental knowledge of Python or something, a language similar?
I think that would help. Yes.
Yeah. So someone coming in without any coding experience, it might be a little tough for them.
Definitely.
Okay. All right. So Even has raised his hand, so I'm going to unmute his microphone and I'll let him ask his question. All right, Evan, go ahead. All right, we can't hear you.
Okay, can you hear me now?
Yep.
All right, thank you. I figured it'd be easier to ask than to write it down. So I'm in the Tech Academy right now.
Nice.
In the AI developer course.
Oh, awesome.
Yeah, thank you. It's very exciting. I've gained a lot more than I've ever gained as far as ground and learning about software development, artificial intelligence. So my biggest barriers, that I can foresee is everything, even the junior developer roles, everything. They want experience or a bachelor's degree or an equivalent in order to begin with a company. And so I'm wondering, like, what can I do to beef up, my candidacy in order to get my foot in the door? I'm 41 years old. I don't have any prior background experience with none of this except for helping out with company web PR, with website development and things of that nature in the background. So I don't have anything solid. I will have a Tech Academy certification, by February at the latest. And aside from that, I just want to get my foot in the door. But it seems very difficult to find a toehold.
So it is a challenging time in the job market right now. That being said, it's frequently a challenging time in the tech job market. And when you get to the end of the Tech Course Academy, one of the things that resonated with me the most is your persistence will be the biggest thing that gets you a job. And I firmly believe that. I think that there are some new techniques specifically for this current climate of ways to succeed in it. And honestly, yes, the certifications are important. Yes, your history is important, but the most important thing in that process is going to be the hustle, unfortunately. And I have plenty of techniques I can share with you that I am in the circles that I'm swimming in right now, having conversations with people about how to navigate this. I'm happy to share those in a conversation, but figuring out a system for yourself that allows you to get to a human and hustle and communicate your value consistently is going to be what lands you a job in this space.
All right, I appreciate that. So basically transferable skills. I thank you.
Yeah, of course. But connect, please. Let's talk more.
Absolutely. I already sent you an invitation.
Love it.
All right, thanks, Evan. And when you say the hustle, Ian, we put it out there. It's kind of networking is key. So you can call it the hustle when you're networking, that kind of thing. But you want to get out and you want to meet people and put yourself out there. Ian has done a great job with that. He's got his own podcast. He has his own meetup group, and he's really putting himself out there and making connections. So connections are key, and networking is key. Any events that you can find to attend, I would highly recommend that. And you can attend those events not just where you are locally, but you can do it online. There are many events online, so I highly recommend those, and I'm sure Ian would too. But it's just really putting yourself out there and really marketing yourself basically with networking. So, all right, great question. And does anyone else have any questions? You can definitely raise your hand or put the question in the chat. All All right, and looks like Petula's put her event in the chat, so you can click on that link. I am clicking on it now, actually, because I do want to see that. And Lauren has a question. Is the certification accredited or just certification of completion? And I'm not sure if that's with the school or with Google. Most of them are just certifications of completion, but it is something you can put on your resume. It is something that will definitely help you with finding work. Accredited, I mean, you kind of have to go to a 2-year or 4-year school for that. But Ian, go ahead, and any more insights on that?
Yeah, no, you hit it on the head. You got it.
All right, and another question for you. So how do you see the role of unstructured data evolving over the next 5 or 10 years?
I mean, personally, the piece that I am most excited about is I feel like the user experience is going to shift dramatically. I feel like for every time up until now, it was the human coming to the computer, but it's going to be the computer coming to the human because it's able to understand the human in ways that was not realistic before. Everybody's talking about right now, 2025 will be the year of the AI agent, where it's not you come to the computer and answer questions, it does work on your behalf. They're calling it service as a software. I do believe that we're going to see more voice, more capability in voice, more capability in video. A friend of mine is building a company called MeBot, where you could send a representation of yourself to a meeting so you don't have to do it. And he was testing it, and he had a picture of John Cleese, the actor from Monty Python, behind him. And the chat bot brought up, "Oh, what's your interest in John Cleese?" which just speaks to, it was not him prompting, it was the other way around. I think there's going to be some incredible developments in that space that I'm very excited about.
Yeah, it'll start to become your personal friend.
Mm-hmm.
And personal assistant. So no, that's good stuff. Does anyone else have any questions for Ian? Okay, so Evan put he put a comment in the chat. I'll just read it. He said the funny thing is the AI field deals with unstructured data and is itself unstructured data at this point. Still coalescing.
Mm-hmm. Very much so.
There you go. Good comment, Evan. Really good. All right, and any other questions? You can raise your hand or you can throw it in the chat. Right, and last question I'll ask you, Ian, what recommendations, and we've kind of covered it, but what recommendations besides networking and, doing the hustle, marketing, that kind of stuff, what other advice would you give for finding work after graduating?
Finding work after graduating. There are, I mean, it falls in the hustle piece, but just developing the systems for yourself that support you to put in the effort consistently over time, because it is that consistency over time that will work. You will probably have to try several different approaches because what worked 3 years ago doesn't necessarily work right now, but talk to people who are in the search and compare notes about what's working and what's not. Reach out to people on LinkedIn. The digital marketplace, especially in technology right now, is the place where a lot of these conversations are happening. So be active.
Sounds good. And what kind of portfolio do you have with GitHub or chatbots, that kind of thing?
Mm-hmm. Yeah, I mean, I think if you have the opportunity to build your own chatbot and throw it in GitHub, it's something you can have a conversation with a hiring manager on in an interview. That's a huge angle. Lots of people are looking for people who are literate in this space.
All right, good stuff, Ian. No, that was a great presentation, great talk, and it is a future, so it's awesome to dig into it. Lauren just threw a question in the chat. So what is the system you can start to establish? And
For your personal system? Is that what the question is?
Yeah, I believe so. Yeah, for finding work and getting into AI and unstructured data.
Yeah. I mean, I think the systems for if the most important thing is to not tie your mood and your motivation to results. Figure out a system of, I will submit 15 applications a week. I will do 25 outreaches a week. I will go to one thing a week, and be happy when you achieve those, because if you consistently do those over time, things will shift. But if you start looking at the number of rejections you have and all of those kind of things, it's demoralizing. Half of the battle is simply figuring out ways to manage yourself in the process. If that's support from friends and family, what all of that looks like, and that system is going to look different for everybody that's in the process. But again, I'm happy to share if you want to connect and go into for each person what that looks like for them.
Okay. Lauren did add to it afterwards. What kind of system could you establish for work if you're working? And Ian, you froze up. Can't hear you at the moment. There you go. You're back. Yep.
Lauren, can you ask? I'm not totally certain what you mean. Do you mean if you have a job versus if you don't have a job? Is that what you mean?
Yeah, it does say for work. So.
Okay.
Yeah.
So if you have a job, and mostly what that means is you can't be as open about it on LinkedIn because you likely don't want your employer to find out about it, and you likely don't have as much time as you would if you are not employed somewhere. So it would be about sending your resumes out in the morning or the evening and using direct message through LinkedIn, because your employer can't see that.
All right. All right. Any other questions? Okay, and Ian, we do appreciate it. And the thing, you can go to Google and get certified, that kind of thing, but you will have to have pre-knowledge with some coding, some Python, that kind of thing. Our school does teach that from the beginning, so you can come in and learn. Our artificial intelligence program does teach Python and what you need before you get into the artificial intelligence and data science portion of the boot camp. So definitely a good way to get certified, and it'll take you anywhere from 3 to 6 months. So good stuff. All right, and Adrian, do you have anything you want to add?
Yes, actually do have.
Go ahead.
Okay, so thank you all for attending today's Tech Talk, and a big thank you for our speaker for today, Ian, for sharing their time, knowledge, and expertise with us today. And we'd really love to invite you again for our future Tech Talks.
I love the Tech Academy. You all are amazing. Thank you.
Thank you. Thank you. So we host Tech Talks every Friday at 1 p.m. Pacific time. In addition to this talks, we also offer other events. It includes free classes like the one happening later today, 5 p.m. And also, you can join our Tech Accelerator program. This is an advanced program that offers dynamic hands-on learning with 100 plus educational videos and live weekly sessions every Tuesday. You can email us at accelerator@learncodinganywhere.com. We'll just paste it on the chat so that you can just copy it. Okay. And as we head into the holiday season, we won't have any scheduled tech talks in the incoming weeks, but stay tuned. Our very first tech talk for 2025 is going to be exciting. So it will focus on landing tech jobs in 2025. And our speaker will be Eric, our co-founder. So he'll be sharing insights on leveraging AI to secure tech roles. And yeah, we also look forward to seeing you at our upcoming events. Yeah, that's all from me, Rick.
Okay, thanks, Adrian. And what's the date of Eric's talk? January?
It's January 10th.
Okay,
Yep,
January 10th. Sounds good.
Yep.
Sounds good, Adrian. Thank you. And Ian, thank you very much for the presentation. That was awesome. We are really happy for your success. Love your enthusiasm, love your passion for it, and it's good to see you in the classroom a couple days a week. So I do look forward to that. Sometimes I get really busy. I apologize for that. But I'm really happy for what you've done and what you've accomplished. Great job.
Thank you all. You guys are awesome.
All right. Thanks, Ian, and everyone else. Have a great weekend, and we will see you in 2025. So have a great holiday season.
Later all.
All right. Bye, all.
Bye, everyone.